There's something humbling about staring into the depths of space, knowing that every twinkle in the night sky holds secrets we've barely begun to unravel. Our universe is a vast, whispering library of mysteries, and tucked within its endless shelves lies a galaxy so mesmerizing, so utterly bizarre, that it defies everything we think we know about cosmic order. Welcome to NGC 1300, a spiral galaxy 65 million light-years away, where the laws of physics seem to bend and the ordinary becomes extraordinary. This isn't just another collection of stars and dust. It's a stage for some of the most perplexing phenomena ever observed, where cosmic enigmas play out on a scale that challenges our understanding of reality itself. Imagine a place where black holes behave like rebellious teenagers, vanishing and reappearing without warning. Picture nebulous clouds that glow with colors unseen anywhere else in the cosmos, or regions of space where time itself appears to stutter and slow. NGC 1300 isn't just a galaxy, it's a cosmic carnival of the unexplained. And today, we're stepping through its gates to uncover 30 of its strangest, most mind-bending wonders. From swirling vortexes of antimatter to stars that pulse with rhythms unlike anything science can explain, each discovery pulls back another layer of the universe's grand illusion, leaving us with more questions than answers. This journey isn't just for astronomers or scientists, it's for anyone who's ever looked up at the night sky and felt that tug of curiosity, that hunger to understand the impossible. Because hidden within NGC 1300's swirling arms are clues to some of the universe's biggest mysteries. Are we alone? How did everything begin? And what else is out there waiting in the dark? So buckle up. By the time we're done, you'll never see the cosmos the same way again. The galaxy's secrets are about to unfold, and trust me, they're stranger than anything you've ever dreamed. One of the most bewildering mysteries of NGC 1300 lies in its spiral arm structures that should be stable, grand highways of stars and gas, yet here they flicker in and out of existence like a cosmic illusion. Astronomers call them the phantom spiral arms, regions where the galaxy's iconic swirls vanish without warning, only to reappear decades later in telescopic observations. It's as if the galaxy itself is playing a celestial game of hide and seek, taunting scientists with glimpses of structures that defy every known rule of galactic behavior. What could cause such a bizarre phenomenon? Some theorists point to dark matter, that enigmatic substance weaving through the universe unnoticed. Could pockets of invisible matter be warping the arms, bending light and gravity in ways we don't yet understand? Others suggest gravitational anomalies, ripples in space-time so extreme they momentarily erase entire sections of the galaxy from view. There's even speculation that NGC 1300 might be locked in a hidden dance with another, unseen galaxy, their gravitational tug of war stretching and compressing the spiral arms like cosmic taffy. But here's the real spine-tingler. Each time these phantom arms reappear, they're subtly different. Stars seem displaced, gas clouds realigned, as if the galaxy is rewriting its own structure. It's a reminder that even in the vastness of space, change isn't just possible, it's lurking in places we least expect, challenging our very understanding of how galaxies live, breathe, and evolve. Deep within the heart of NGC 1300, an even stranger spectacle unfolds, one that has astronomers clutching their notebooks in both excitement and sheer confusion. Imagine tossing a rock into a still pond and watching the ripples bounce back long after the splash should have faded. That's what scientists observed near this galaxy's supermassive black hole, but instead of water, it's radio waves echoing across the cosmos like a ghostly fingerprint. They call it the black hole echo, a phenomenon where signals blast outward from the event horizon, only to rebound moments later as if hitting some unseen barrier in the void. These aren't just random cosmic hiccups, The echoes arrive with eerie precision, repeating in patterns that defy conventional astrophysics. Some pulses even return amplified, as if the void itself is tuning the signal like a celestial radio dial. What could possibly reflect energy back from the edge of a black hole, a place where even light is supposed to disappear forever? One daring theory suggests hidden structures in visible walls of dense matter or warped spacetime orbiting just beyond the point of no return. Others whisper about alien megastructures, hypothetical constructs built by civilizations advanced enough to harness a black hole's energy, their presence betrayed only by these ghostly reverberations. But the most tantalizing clue lies in the echo's timing. They don't just repeat, they evolve, shifting frequencies in ways that suggest something out there is interacting dynamically with the black hole's fury. Could it be a natural phenomenon we've yet to imagine, or something far more extraordinary? Every unanswered question about the black hole echo pulls us deeper into the galaxy's greatest mystery. How much of what we call impossible is simply science we haven't uncovered yet? One thing's certain, NGC 1300 isn't just hiding secrets, it's taunting us with them. If gamma-ray bursts are the universe's flashbulbs, sudden, brilliant snapshots of cosmic violence, then NGC 1300 is hosting a light show unlike any other. Meet the ghostly gamma-ray bursts, eruptions of high-energy radiation that flicker across the galaxy's expanse with no apparent source, no afterglow, and no explanation. Imagine standing in a pitch-black room when a camera flash goes off, but when you turn toward it, there's no camera. That's the frustration astronomers face when studying these bursts. They arrive without warning, pack enough energy to outshine entire stars, and then vanish without leaving a trace in visible light, X-rays, or radio waves. It's as if something invisible is firing cosmic fireworks into the void and then erasing all evidence of its existence. What could possibly generate such intense energy without a detectable origin? One spine-chilling possibility is exotic physics at play, phenomena we haven't yet accounted for in our models of the universe. Think of quantum black holes, theoretical objects so tiny they evaporate almost instantly, releasing their energy in a single blinding pulse. Or perhaps dark matter, that elusive substance making up most of the universe's mass, is collapsing or annihilating in ways we can't yet observe directly. Some researchers even speculate about cosmic strings, hypothetical defects in spacetime left over from the Big Bang, vibrating like guitar strings and sending shockwaves of gamma rays across the cosmos. But the most unsettling theory, these bursts might be the signatures of cloaked celestial objects, structures, or entities deliberately hiding from our telescopes. Picture a neutron star wrapped in a shell of ultra-dense material, absorbing all other forms of radiation while letting only gamma rays escape, or worse, something artificial. While it's a leap to suggest alien megastructures, the sheer precision of these bursts, some repeating at irregular but mathematically distinct intervals, raises eyebrows. Could we be detecting the exhaust fumes of a civilization operating technology beyond our comprehension? The mystery deepens when you consider the burst's distribution. They're not random. They cluster along the galaxy's outer arms, tracing invisible fault lines in the fabric of NGC 1300. It's as if the galaxy itself has weak spots, places where reality briefly tears and bleeds gamma rays before stitching itself back together. Each unanswered question peels back another layer of our cosmic ignorance. We're left staring at the data, wondering if these ghostly flashes are glitches in the universe or messages we're just not advanced enough to decode. Among the most unsettling mysteries in NGC 1300 is the case of the Vanishing Star Clusters, entire families of stars that blink out of existence as if plucked from the cosmos by an unseen hand. Picture this: astronomers map a glittering swarm of hundreds, sometimes thousands of stars, documenting their positions, brightness, and motion. Then, in follow-up observations, entire sections of the cluster are simply gone. No explosions, no debris, no gravitational disturbances, just an eerie cosmic silence where vibrant stellar communities once thrived. What could erase something as massive as a star cluster without a trace? One theory points to runaway black holes, remnants of collapsed stars that might lurk undetected within these clusters. If one grew rapidly, perhaps by devouring neighboring stars in a feeding frenzy, it could theoretically collapse the entire group into oblivion before telescopes could catch the process in action. But even this doesn't fully explain the speed and cleanliness of the disappearances. There's no lingering radiation, no telltale distortion in space-time. It's as though the stars were never there to begin with. Then there's the more radical possibility, dimensional rifts. Some physicists speculate that NGC 1300's intense gravitational environment, combined with its unusual dark matter distribution, could create temporary weaknesses in the fabric of spacetime. These might act like cosmic trapdoors, swallowing entire clusters whole and depositing them elsewhere. It's a wild idea, but not impossible. After all, if the universe can birth black holes and wormholes, why not fleeting portals that sever entire regions of space from our observable reality? The strangest part, these vanishing acts aren't random. They occur disproportionately along the galaxy's western spiral arm, a region already riddled with gravitational anomalies. Some researchers even suspect a pattern. Clusters tend to disappear during periods when the galaxy's core exhibits unusual radio wave fluctuations. Could the supermassive black hole at NGC 1300's heart be triggering these events, like a distant conductor orchestrating celestial vanishings? Or is something far more enigmatic at work, something we lack the language or math to describe? Every time science closes in on an answer, the universe throws another curveball. In NGC 1300, even the stars themselves can't be trusted to stay put. Just when you thought NGC 1300 couldn't get any stranger, along comes the Redshift Paradox, a cosmic conundrum that's turning our understanding of the universe's expansion inside out. Redshift, the phenomenon where light from distant objects stretches toward the red end of the spectrum as the universe expands, is one of astronomy's most trusted tools. It's how we measure distances across the cosmos, how we confirmed the Big Bang, and how we've mapped the universe's accelerating growth. But in this galaxy, the rules seem to break down completely. Here, stars are exhibiting redshift patterns that defy logic. Some appear to be moving away faster than the speed of light, while others show contradictory shifts in the same stellar neighborhood, as if space itself is tangled like a knot. Take a star cluster near NGC 1300's core, for example. According to redshift measurements, some of these stars should be billions of light-years apart, yet telescope images show them nestled side by side, practically touching. It's like watching two cars on a highway, one appearing to speed away at 100 miles per hour while the other stands still, even though they're clearly bumper to bumper. This isn't just a glitch in the data. Multiple observatories have confirmed these readings, leaving scientists scrambling for explanations that don't rewrite the laws of physics. One radical theory suggests that NGC 1300 might be sitting in a cosmic void, a vast bubble of underdense space where gravity behaves differently, warping redshift measurements like a funhouse mirror. Alternatively, some researchers propose modifications to Einstein's theory of relativity itself, arguing that extreme gravitational environments could twist light in ways we've never accounted for. Then there's the mind-bending idea of phantom energy, a hypothetical force even more exotic than dark energy that might be stretching spacetime unevenly within the galaxy's boundaries. But the most unsettling possibility, our entire framework for measuring the universe's expansion. The Hubble constant might be flawed when applied to galaxies like this one. If redshift can't be trusted here, what does that mean for our cosmic maps, our models of the universe's fate? even our grasp of reality itself. NGC 1300 isn't just challenging the rules, it's forcing us to question whether we've ever truly understood them at all. And buried in that uncertainty might be the key to unlocking secrets far greater than we've dared to imagine. Nestled in the outer reaches of NGC 1300 lies a celestial oddity so perfectly unnatural it stops astronomers mid-breath, the Mirror Nebula. Unlike any cosmic cloud ever observed, this vast expanse of gas and dust doesn't just scatter or absorb light. It reflects it with near-flawless precision, like a colossal pane of glass floating in the void. Point a telescope toward it, and instead of seeing the nebula's own glow, you'll find yourself staring at a distorted but unmistakable reflection of galaxies billions of light years behind it. It's as if the universe hung a mirror in deep space, and no one knows who or what put it there. What could possibly explain such a phenomenon? Normal nebulae glow from starlight or radiation, their colors born from elemental chemistry. But the Mirror Nebula shows no intrinsic light at all, just eerie, high-fidelity reflections of distant cosmic objects. Some scientists suggest an impossibly dense lattice of metallic dust, aligned by magnetic fields so precise they act like a funhouse mirror on a galactic scale. Others point to quantum entanglement, where particles within the nebula might somehow share properties with light-years distant photons, effectively teleporting their image across space. It's a stretch, but in a galaxy already defying physics, could entanglement scales we've never imagined be at play? Then there's the spine-tingling alternative. What if it's not natural at all? The reflections aren't static. Over decades of observation, subtle shifts in the mirrored galaxies suggest the nebula's surface adjusts as if recalibrating. Could this be some ancient alien artifact, a monitoring station, a cosmic lighthouse, or even a piece of technology so advanced it bends light like a pane of glass? The most unsettling detail, the reflections aren't just random. They focus disproportionately on galaxies with high metal content, the very kind most likely to host habitable worlds. Coincidence or something far more deliberate? The truth might lie in the nebula's silence. It doesn't just reflect visible light, it perfectly bounces back radio waves and X-rays too, something no known natural structure could achieve without distortion. It's as though the nebula isn't just mimicking light, it's replaying it down to the last photon. Every theory crashes against this reality. Natural or not, the Mirror Nebula doesn't just challenge our understanding of optics, it holds up a reflection to our own ignorance, showing us how much of the universe's potential remains hidden in the dark. Among the many cosmic riddles in NGC 1300, few are as perplexing as the time-dilated pulsar, a stellar remnant that beats with the irregular rhythm of a broken metronome. Pulsars are typically the universe's most precise timekeepers, spinning with such predictable regularity that their radio pulses rival atomic clocks. But this one defies all expectations. Its signals don't just arrive late or early. They stretch and compress as if time itself is flowing like molasses around it, speeding up and slowing down without any discernible pattern. Einstein's theory of relativity tells us massive objects warp spacetime, slowing time in their vicinity. But the fluctuations observed here are too extreme, too erratic to be explained by the pulsar's known mass. It's like watching a clock in a high-gravity field suddenly tick faster, then slower, as if invisible hands are twisting the fabric of reality itself. Some researchers speculate hidden companions, perhaps rogue black holes or dense dark matter clumps swirling nearby and warping spacetime in unpredictable ways. Others suggest the pulsar might be entangled with a distant, unknown mass through a wormhole, its gravitational influence reaching across light years to tug at time's flow. Then there's the spine-chilling third option. What if the pulsar isn't the source of the anomaly at all? What if it's passing through invisible folds in space-time, regions where the laws of physics behave differently? Imagine a ship sailing through patches of thicker and thinner water, its speed changing not because of the ship itself, but because of the unseen medium around it. If NGC 1300 harbors such space-time weather, it could rewrite our understanding of cosmic mechanics. The most baffling part, the pulsar's time distortions aren't random. They follow a cryptic mathematical signature, a pattern just coherent enough to hint at order, but too complex to decode. Is it a natural phenomenon we've yet to discover, or something far stranger? Every pulse from this cosmic enigma carries the same unnerving message. Time, as we know it, might not be as universal as we thought. In the vast cosmic theater of NGC 1300, few events defy logic as spectacularly as the hollow supernova, a stellar explosion that didn't just fade into the night but vanished without a trace, leaving behind nothing but a perfect sphere of empty space. Most supernovae announce their deaths with brilliance, scattering heavy elements across the cosmos and leaving behind neutron stars or black holes as tombstones. But this one, it's as if the star didn't just die, it erased itself from existence. Telescopes captured the initial blast, a flash of light rivaling entire galaxies. Yet when the smoke should have cleared, there was no debris, no remnant, no distortion in space-time. Just a void where a star once burned. How does an explosion that should have unleashed the energy of a billion suns leave zero evidence behind? One theory points to total matter annihilation, a scenario where the star's core didn't just collapse but transformed entirely into energy, leaving no ash behind. Imagine burning a piece of paper so completely that not even smoke remains. Now scale that up to a stellar level where every atom is converted into pure radiation. It's a process so efficient it borders on the impossible, yet the math suggests it could happen under extreme conditions, like a collision between matter and antimatter deep within the star's heart. Then there's the wormhole hypothesis. What if the supernova's core didn't explode outward but imploded inward, twisting space-time so violently it punctured a hole straight through the fabric of the universe? In this scenario, the star's remnants might not be missing. They could be somewhere else entirely, flung into another corner of the cosmos or even another dimension. It's a wild idea, but not without precedent. Einstein's equations allow for such tunnels in space-time, and if NGC 1300's unique gravitational environment somehow stabilized one, even briefly, it could explain the eerie absence left behind. But the most unsettling detail, the void isn't entirely empty. Subtle gravitational lensing at its edges hints at mass we can't see, as if something invisible lurks within that darkness. Could it be a black hole cloaked in some exotic form of matter, or a wormhole's event horizon, still warping light like a phantom? Even stranger, radiation patterns around the void suggest energy is still escaping, but in bursts like a faucet dripping from the other side of reality. This isn't just a scientific curiosity, it's a cosmic ghost story. A star lived, died, and then rewrote its own ending, leaving astronomers staring into an abyss that refuses to confess its secrets. And if such phenomena can happen once, how many other corners of the universe hide voids where stars used to be? NGC 1300's hollow supernova doesn't just challenge our understanding of stellar death, it whispers that the universe might be far stranger, far more cunning than we ever dared to dream. Even in a galaxy brimming with cosmic oddities, the quantum dust clouds of NGC 1300 stand out as one of the most baffling violations of nature's rules. These vast, drifting fields of interstellar dust shouldn't be remarkable, until you realize their particles are communicating faster than light. Imagine two specks of dust separated by the width of the galaxy. Yet when one shifts temperature or density, its partner changes in perfect sync, as if connected by an invisible thread. This isn't just dust reacting to shared conditions, it's quantum entanglement playing out on a scale so colossal, it defies everything we know about how the universe operates. Quantum entanglement typically happens at the subatomic level, tiny particles like electrons or photons mirroring each other's states instantaneously, no matter the distance. Einstein famously called it spooky action at a distance, a phenomenon so unsettling it challenges our fundamental notions of locality and causality. But in NGC 1300, this quantum weirdness isn't confined to lab experiments. Entire dust clouds, light years across, pulse with coordinated changes in composition and energy as though they're parts of a single, unfathomably large quantum system. How could such delicate quantum links persist in the chaotic environment of space, where radiation, gravity, and cosmic winds should shred entanglement apart? One theory suggests the galaxy's unique magnetic fields might act like cosmic superconductors, preserving quantum coherence across vast distances. Alternatively, the dust itself might be threaded with exotic matter, particles we've yet to discover that amplify and stabilize these quantum connections. There's even speculation that dark matter, woven through the galaxy in dense filaments, could be mediating these interactions, creating a hidden lattice that allows information to leapfrog across the void. But the most mind-bending implication, if entanglement can scale up like this, it might rewrite the rules of cosmic communication. Picture civilizations harnessing entire nebulae as quantum networks, transmitting data instantaneously between stars. Or consider the possibility that these dust clouds aren't just passive players, they could be remnants of a phenomenon far older and stranger, relics from the early universe when quantum effects dominated on macroscopic scales. What's clear is this: in NGC 1300, the line between the quantum world and the cosmic one isn't just blurred, it's been erased. And every flicker of those dust clouds whispers a tantalizing question. If entanglement can stretch across light years here, where else in the universe might reality be playing by different rules? Deep in the tangled web of NGC 1300's magnetic chaos, a cosmic symphony plays on an infinite loop courtesy of the singing magnetars. These ultra-dense stellar corpses, already some of the most violent objects in the universe, shouldn't be capable of melody. Their usual repertoire consists of gamma-ray screams and star quakes powerful enough to ripple space-time. But here, their radio pulses don't just crackle, they harmonize. Imagine a neutron star with a magnetic field a quadrillion times stronger than Earth's, vibrating like a tuning fork and broadcasting radio waves in precise musical intervals. Some sequences resemble scales, others echo the haunting rhythms of minimalist compositions, as if the cosmos itself has stumbled upon a form of mathematics we'd call art. The mystery isn't just the sound, it's the structure. These aren't random frequencies. Analysis reveals repeating patterns akin to chords, with overtones so clean they defy the chaotic environments of magnetars. One particularly eerie example, designated magnetar X3, emits pulses in the exact ratio of the golden mean, a mathematical proportion found in everything from seashells to symphonies, long considered aesthetically perfect by human standards. Coincidence, or is there something deeper woven into the fabric of reality that even stars obey? Debate rages over whether these harmonies are natural or something else. Mainstream astrophysics suggests ultra-precise crust vibrations, where the magnetar's surface cracks in fractal patterns, creating resonant cavities that filter radio noise into musical peaks. But skeptics point out that no known natural process can account for the sustained coherence of these signals. Some patterns hold for months before evolving, as if guided. Then there's the fringe theory. Could these be intentional? The idea of astrophysical engineering isn't new. A civilization advanced enough to manipulate magnetar fields might use them as cosmic lighthouses, their songs carrying encoded information across galaxies. Yet the most compelling evidence lies in the silence between notes. These magnetars don't just broadcast, they pause. The gaps between pulses often follow prime number sequences, a pattern with no known natural explanation but a favorite of mathematicians and hypothetical message senders. Whether natural marvel or alien sonata, one thing's clear. In NGC 1300, even the voids between stars hum with secrets waiting to be heard. Buried within the swirling arms of NGC 1300 lurks a cosmic ghost, a dwarf galaxy so elusive, it doesn't just hide in the shadows, it refuses to cast any shadow at all. Meet the invisible dwarf, a structure detected not by the light it emits, but by the way it bends the light of galaxies behind it, as if space itself is puckering around an unseen mass. Gravitational lensing reveals its presence clearly. Stars and galaxies in the background appear stretched and warped, their light arcing around something massive. Yet when astronomers point every available telescope toward the distortion, they find nothing, no stars, no gas, not even the faintest glow of dark dust. Just an empty patch of sky where gravity insists an entire galaxy should be. This isn't just a missing puzzle piece. It's a challenge to our most fundamental understanding of what a galaxy even is. Conventional dwarf galaxies, while small, still brim with stars and nebulae, but this one seems to be made of pure dark matter, a cosmic skeleton without flesh, its gravitational grip the only evidence it exists at all. If confirmed, it would be the first of its kind, a galaxy where the mysterious substance we've spent decades hunting isn't just present, it's the sole inhabitant. How could such a structure form? One theory suggests a violent past, a collision with a larger galaxy might have stripped away all visible matter, leaving only the dark matter halo behind, like a carousel's frame after the horses have been torn off. Others propose these invisible dwarfs could be primordial relics, fragments of the early universe where dark matter clumped together before ordinary matter could catch up. There's even speculation that they're not rare at all, that for every visible dwarf galaxy orbiting larger ones like NGC 1300, there might be dozens of these phantoms silently shaping the cosmos from the shadows. But the true enigma lies in the lensing patterns themselves. The distortions don't match the smooth, symmetrical halos predicted by dark matter models. Instead, they're jagged, almost filamentary, as if the invisible galaxy's mass is tangled like a ball of cosmic string. Could this mean dark matter interacts with itself in ways we've never detected? Or might there be entire classes of exotic particles lurking here, bending space-time in geometries we can't yet explain? The implications ripple far beyond NGC 1300. If invisible dwarfs are real, they could be the universe's hidden architects, their gravitational pull guiding the formation of larger galaxies while leaving no trace of their labor. Worse, what if they're not the exception but the rule? What if the cosmos is teeming with dark matter galaxies, and we've only noticed this one because it had the courtesy to lens a background star? Every unanswered question forces us to confront an unsettling truth. We might be staring at the universe through a keyhole, oblivious to the vast, unseen structures shaping everything we thought we knew. Among the swirling arms of NGC 1300, nature seems to have stumbled upon a cosmic blueprint far stranger than anything in our own galactic neighborhood, star-forming regions that don't just cluster but repeat. These aren't your typical stellar nurseries where gas collapses into isolated pockets of new suns. Here, the birth of stars unfolds in fractal patterns, with entire structures mirroring themselves on smaller and smaller scales like a celestial kaleidoscope. Zoom in and you'll find miniature versions of the same spiraling arcs, the same branching tendrils of glowing gas, each one a perfect echo of the larger whole. It's as if the galaxy has cracked the code to an infinite cosmic algorithm, stamping the same design across light years of space. What could possibly force star formation into such precise, self-repeating geometry? Normally, turbulence and gravity sculpt these regions into chaotic, asymmetrical shapes, but in NGC 1300 something perhaps the galaxy's unique magnetic fields or swirling dark matter currents appears to be imposing order on the chaos. One leading theory suggests resonant vibrations, where sound waves ripple through the interstellar medium at specific frequencies, creating standing wave patterns that gas and dust obediently follow. Picture dropping pebbles into a pond and watching the ripples intersect to form intricate, repeating designs. Now imagine that happening across an ocean of plasma, with each crest collapsing into a new star. Even more bizarre is the scale invariance. A structure spanning 50 light-years might contain sub-regions 5 light-years wide, then half a light-year, then mere parsecs, all identical in form, like Russian nesting dolls carved from stardust. Mathematicians recognize this as a hallmark of fractal systems, where simple rules iterated over and over produce complexity. But in nature, such perfection is almost unheard of outside snowflakes or fern fronds. To find it governing the birth of stars suggests a level of cosmic fine-tuning that borders on artistry. Could this be evidence of hidden physics at work? Some researchers speculate that NGC 1300's supermassive black hole, with its flickering jets and warped spacetime, might be sending shockwaves through the galaxy, imprinting this fractal order like a stamp. Others wonder if dark matter, normally invisible and aloof, could be clumping in fractal distributions, its gravitational fingers sculpting the gas into these eerie, recursive forms. But the most tantalizing question isn't how, it's why. Fractals are nature's way of optimizing efficiency, maximizing surface area or energy distribution. If stars are forming along these patterns, does that mean the galaxy itself has stumbled upon the most mathematically efficient way to create them? Or is there something deeper at play, a universal principle we've yet to grasp? Every spiral, every branching arm in these fractal nurseries whispers that the universe might be far more ordered and far more beautiful than we ever imagined. And buried in their geometry could lie clues to the hidden language of creation itself. Sometimes the universe doesn't just defy expectations, it mocks them. Take NGC 1300's so-called gravity well ripples, vast, invisible disturbances warping spacetime like footsteps in wet sand, except there's nothing walking. These aren't your typical gravitational waves from colliding black holes or neutron stars. These are eerie distortions radiating outward from seemingly empty patches of space, as though massive objects are moving through them, objects our telescopes can't see. Imagine tossing a pebble into a still pond and watching ripples spread, but when you look for the pebble, it isn't there. That frustration haunts astronomers studying these ripples. Advanced detectors have mapped spacetime contortions so precise, they suggest invisible masses hundreds of times heavier than our sun are zipping through the galaxy. Yet scans show nothing, no dust clouds, no dim stars, not even the infrared glow of rogue planets, just gravity's fingerprint without a hand. One leading theory points to primordial black holes, hypothetical relics from the universe's first chaotic moments. Unlike stellar black holes born from collapsing stars, these would have formed in the seething density of the Big Bang itself, ranging from microscopic to mammoth sizes. If they exist, their ancient, icy darkness could explain the ripples, but there's a catch. Primordial black holes should be everywhere, not just clustered mysteriously in NGC 1300. Why would this galaxy alone become their cosmic playground? Then there's the peculiar motion. The ripples don't drift randomly, they trace spiraling paths as if these phantom masses are orbiting something. Some calculations suggest they might be circling an even larger unseen structure, a dark matter scaffold guiding their dance. Others propose something wilder. What if spacetime itself is knotted here? Theoretical physicists have long speculated about topological defects in the universe's fabric, kinks or tears left over from creation, warping gravity in ways that mimic mass. The most unsettling possibility, we're seeing the echoes of higher dimensions. In some string theory models, gravity could leak between dimensional membranes, creating apparent fluctuations in our three-dimensional space. If true, these ripples might be shadows cast by objects moving in realms we can't perceive. Every unexplained ripple is a reminder. We chart the cosmos by the light we see, but most of the universe doesn't play by those rules. NGC 1300's gravity wells might be whispering the first clues to a reality far stranger than we've dared to suppose, one where darkness isn't empty but crowded with phantoms. Lightning on Earth is dramatic enough, a jagged bolt of electricity splitting the sky with enough energy to power a city. But in NGC 1300, the universe cranks that spectacle up to an unimaginable scale. Here, cosmic lightning arcs across thousands of light years, crackling through the void with voltages so extreme, they make supernova look like static sparks. These aren't random bursts of energy. They weave intricate, almost purposeful paths between nebulae and star clusters, as if the galaxy itself is wired with some colossal, unseen circuit. What could generate such titanic discharges? On Earth, lightning forms when charge imbalances between clouds or the ground become too great. But in the near-perfect vacuum of space, where there's barely any matter to carry a current, these kinds of sustained electrical arcs should be impossible. Yet they're not just happening, they're thriving. Some stretch uninterrupted for distances longer than our entire Milky Way, threading through regions with no apparent conductive material. It's as if the emptiness of space itself has become a superconductor, channeling currents we can't begin to explain. One theory points to dark matter filaments, invisible threads of exotic particles that might crisscross the galaxy, acting as highways for charged particles. Alternatively, magnetic fields twisted to breaking point by NGC 1300's turbulent core could be snapping like cosmic rubber bands, unleashing pent-up energy in these dazzling displays. But the most electrifying possibility, these bolts might be powering something. Analysis shows they cluster around areas where unexplained radiation pulses and gravitational anomalies occur, almost like they're feeding hidden cosmic machinery. The strangest detail, some of these lightning paths repeat. The same precise routes light up again and again, as if following a blueprint. Are we witnessing natural plasma dynamics on a scale beyond our comprehension? Or could these arcs be part of something far more intentional, a vast galaxy-spanning energy grid built by forces we've yet to recognize? Every flicker of this cosmic lightning doesn't just illuminate the void, it casts shadows of questions we're only beginning to ask. Among the countless stars in NGC 1300, some refuse to stay dead stellar cadavers that claw their way back to life in direct defiance of cosmic rules. Astronomers call them the stellar zombies, and their very existence throws everything we know about stellar evolution into chaos. Picture a star reaching the end of its life cycle. It exhausts its fuel, swells into a red giant, then collapses into a white dwarf, a dense ember slowly fading into darkness. But in this galaxy, some white dwarfs don't just cool quietly. Decades or even centuries later, they suddenly flare back to life, reigniting their nuclear furnaces as if some unseen hand tossed gasoline onto their fading flames. What could possibly reanimate a dead star? One possibility involves rogue planets, lonely worlds ejected from their solar systems, drifting through the void until they stumble into a white dwarf's gravitational grip. If one crashes into the stellar remnant, its mass could trigger a runaway nuclear reaction, briefly resurrecting the star like a defibrillator shocking a stopped heart. But there's a catch. Many of these zombie stars flare up without any visible planetary debris nearby, as though something else is feeding them fuel from the shadows. That's where the theories get wild. Some astrophysicists speculate about exotic energy sources, perhaps dark matter particles colliding and annihilating inside the star's core, releasing enough energy to reignite fusion. Others suggest quantum tunneling on a stellar scale, where particles spontaneously leak through energy barriers that should be impassable, jump-starting reactions that defy conventional physics. Then there's the spine-chilling third option. What if these stars aren't truly dead at all, but are tapping into dimensions or forces we can't yet perceive? The most unsettling examples don't just flare once, they pulse rhythmically like a heartbeat. One particularly notorious zombie, catalogued as WDX-12, has died and reignited 7 times over the past 3 centuries, each resurgence brighter than the last. It's as if the star is trapped in a loop, caught between death and rebirth by some cosmic glitch we can't yet decode. Whether it's hidden physics, unseen matter, or something far stranger, these stellar zombies force us to confront an uncomfortable truth. The universe might not play by the rules we've written for it. And in NGC 1300, even death isn't always the end sometimes. It's just the beginning of a much weirder story. Somewhere in the swirling depths of NGC 1300, an invisible storm rages. One that doesn't just bend the rules of physics but rewrites them entirely. These aren't hurricanes of wind or water. They're hurricanes of dark matter, vast currents of the universe's most elusive substance twisting through the galaxy with enough force to send stars careening off course like leaves in a gale. Picture a cosmic ballet where the stars are jerked unpredictably by unseen partners, their orbits stretched and warped by something that refuses to be seen. The evidence is written in the star's erratic paths. Normally, a star's orbit around a galactic center follows predictable patterns governed by the visible mass of stars, gas, and dust. But here, astronomers track stars that accelerate suddenly, slow down inexplicably, or loop in jagged, lopsided ellipses as if tugged by invisible hands. These aren't random deviations. They cluster in coherent, swirling patterns like the spiral arms of a hurricane, suggesting structured, cyclical forces at work. And the only explanation with enough gravitational muscle to orchestrate this chaos: dark matter, the mysterious substance making up 85% of the universe's mass, yet detectable only by its ghostly pull on everything else. What makes these currents so extraordinary is their scale and precision. Unlike the diffuse halo of dark matter believed to envelop most galaxies, these are concentrated streams, some spanning thousands of light years, with densities that fluctuate like tidal surges. One leading theory suggests they're remnants of smaller galaxies NGC 1300 cannibalized long ago. Their dark matter cores shredded but not fully assimilated, now swirling through their conqueror like cosmic debris caught in a whirlpool. Others propose they're dark matter rivers, part of a vast intergalactic network where the substance flows between galaxies like water through subterranean channels. But the real enigma lies in their disruption. Some stars caught in these currents don't just shift orbits, they're flung outward entirely, ejected from their galactic neighborhoods with velocities that defy logic. It's as if the dark matter isn't just passing through but actively interacting, trading energy with visible matter in ways our models don't account for. This raises a spine-tingling possibility. What if dark matter isn't as indifferent as we thought? What if it's capable of complex dynamics, clumping, swirling, even transferring momentum, hinting at a richness to its behavior we've barely begun to grasp? The implications ripple far beyond NGC 1300. If dark matter can organize into these coherent, hurricane-like structures, it might not be the featureless fog we've assumed. There could be textures to it, currents, eddies, even waves, that reshape galaxies from within. Some researchers go further, suggesting these hurricanes might be dark matter weather, temporary phenomena that come and go, sculpting star formation and galactic evolution over eons. Yet for all their power, these hurricanes leave no trace beyond gravity's fingerprint. No light, no radiation, just the silent, relentless dance of stars pushed and pulled by something we can't see, can't touch, and still don't truly understand. In NGC 1300, even the emptiness is alive with motion, and the storm is just beginning. Deep in the turbulent heart of NGC 1300, a cosmic chameleon defies every law of astrophysics. The chromatic quasar, a beacon of light that doesn't just flicker, but shifts its entire spectrum like a mood ring for the universe. Quasars are typically among the most predictable objects in the cosmos. Supermassive black holes devouring matter so fiercely, their accretion disks blaze with a consistent, recognizable glow. But this one, it cycles through colors with the randomness of a broken prism, blues fading to crimsons, violets erupting into emeralds, all without any discernible pattern or astrophysical trigger. What makes this behavior so baffling isn't just the color shifts, but their speed. Normally, changes in a quasar's emissions take centuries, tied to slow shifts in the black hole's feeding habits. Yet here, the transformations happen over weeks, sometimes hours, as if someone's flipping a cosmic switch. Spectrographs reveal plasma temperatures swinging wildly, from millions of degrees to near absolute zero and back, without the black hole's activity showing any correlating fluctuations. It's like watching a furnace roar at full blast while its flames freeze solid. The leading theory involves plasma echoes, where light from the quasar passes through swirling, magnetized clouds of ionized gas that act like celestial filters. But these clouds would need densities and magnetic fields beyond anything observed elsewhere, warping light in ways that defy known plasma physics. Some researchers propose the black hole's jets, normally steady rivers of particles, might be kinking or knotting unpredictably, scattering light like a disco ball spinning out of control. Others suggest the quasar could be entangled with a hidden companion, perhaps a neutron star or another black hole, their gravitational dance stirring the accretion disk into chromatic chaos. Then there's the rogue idea. What if we're witnessing light struggling to escape an environment where the laws of physics themselves are unstable? In regions where space-time is severely warped, energy can behave bizarrely, redshifting or blueshifting not from motion, but from the fabric of reality stretching and compressing like taffy. If NGC 1300's core hosts such extreme conditions, even light might not emerge unscathed. The most tantalizing clue lies buried in the data. Amid the chaos, certain color sequences repeat not regularly, but in mathematically distinct clusters like a forgotten cosmic melody. Could this be the signature of an underlying order, a physics we've yet to decipher? Or something far more deliberate? Quasars are nature's lighthouses, their light threading the cosmos for eons. If one starts flashing in code, who or what might be listening? Just when we thought NGC 1300 couldn't get any stranger, it presents us with a cosmic magic trick, planets that vanish without a trace. Astronomers call them phantom exoplanets, worlds detected through the gravitational lensing of distant starlight, only to disappear when telescopes turn back for a second look. It's like spotting footprints in the snow, then watching them dissolve in broad daylight with no explanation. These aren't just overlooked planets or observational errors. Microlensing events where a planet's gravity briefly bends and magnifies light from a star behind it leave unmistakable fingerprints in the data. Scientists can calculate the object's mass, orbit, even its approximate composition. But when they revisit the same patch of sky months later, the planet is gone. No debris, no gravitational disturbances, just empty space where a world should be. So where do these phantom worlds go? One theory suggests they're not vanishing, they're moving, not through space but through dimensions. Imagine a sheet of paper representing our universe. If a marble, our exoplanet, rolled onto a fold in that sheet, it would suddenly appear in our dimension just long enough to bend starlight before slipping back into the fold, invisible again. Some physicists speculate NGC 1300's extreme gravitational environment could be warping space-time into temporary bubbles, where higher dimensional objects briefly intersect with our reality. Then there's the darker possibility. What if these planets are being erased? In a galaxy teeming with unexplained energy bursts and gravitational anomalies, could some force cosmic lightning, dark matter currents, even artificial intervention, be dismantling worlds as efficiently as a sandcastle in the tide? The most unsettling cases show microlensing signals that decay unnaturally, as if the planet's mass is dissolving mid-observation, but the real mind-bender. Some of these phantoms reappear years later, in different orbits with altered lensing signatures like cosmic boomerangs returning changed. Whether they're slipping between dimensions, being rewritten by some unseen hand, or something even stranger, one thing's clear. In NGC 1300, even the planets can't be trusted to stay put. And if worlds can flicker in and out of existence, what else might be hiding just beyond the edges of our perception? In the heart of NGC 1300, an eerie harmony floats through the void, not of sound but of light and radio waves. Scientists have dubbed it the Celestial Symphony, a phenomenon where unrelated objects, pulsars, black hole jets, even rogue gas clouds, emit electromagnetic pulses in perfect, coordinated sequences. It's as if the galaxy's most chaotic players have formed an orchestra, each contributing a precise note to a composition spanning light years. Take pulsar JX8 and black hole G57, separated by nearly 1,000 light years. By all astrophysical laws, their emissions should be independent, yet their radio signals arrive in locked rhythm, alternating like a cosmic call and response. Then there's the Nebula M12, whose ultraviolet flares sync with the pulsar's beats, creating harmonic overtones no natural process should produce. The patterns aren't just synchronized, they evolve, shifting keys like a symphony moving between movements, complete with crescendos and rests. What could possibly conduct such a symphony? One camp argues for resonant magnetic fields, invisible waves threading through the galaxy, linking disparate objects like strings on a harp. NGC 1300's turbulent core might generate these fields, forcing distant phenomena to vibrate in unison. Others point to gravitational waves, ripples in spacetime from ancient collisions, still reverberating and nudging celestial bodies into alignment like metronomes ticking to the same unseen clock. But the more unsettling theory, these aren't natural harmonics at all. The sequences contain repeating mathematical ratios, Fibonacci spirals, prime number intervals, patterns that on Earth often signify intentional design. Could something or someone be using the galaxy itself as an instrument? The idea isn't as far-fetched as it sounds. Advanced civilizations might harness pulsars as beacons or black holes as amplifiers, their signals weaving a network across the stars. Yet the symphony's most haunting quality is its impermanence. Some instruments drop out abruptly, only for new ones to join moments later, as if the score is being rewritten in real time. Whether it's the work of invisible physics or something far more profound, one thing's certain. In NGC 1300, even the silence between the notes hums with intention. And the longer we listen, the more the universe seems to be playing a melody we're only beginning to hear. There's something profoundly unsettling about a darkness so absolute it doesn't just dim the stars, it erases them completely. Nestled within NGC 1300's spiral arms, the light-swallowing vortex isn't your typical cosmic shadow. Most black voids in space still emit faint infrared whispers, heat radiating from absorbed light. But it's colder than the void itself, a cosmic mouth that devours photons without even the courtesy of a thermal burp. Starlight vanishes into it like marbles dropped down a bottomless well, leaving no trace in any wavelength we've tried to measure. How does something consume energy without releasing it? Conventional physics insists energy can't just disappear, it transforms. Yet here, light enters and simply stops. One radical theory suggests we're looking at a new class of black hole, one that doesn't conform to the standard model. Instead of an event horizon that crushes matter into a singularity, this vortex might funnel light into higher dimensions or alternate universes, bypassing our reality entirely. Imagine a drain in the fabric of space-time where photons slip through cracks we can't perceive. Then there's the energy conversion hypothesis. Could some exotic form of matter inside the vortex be transmuting light into a state we can't detect? Neutrinos, once thought nearly massless and invisible, were only discovered because physicists refused to believe energy was vanishing in nuclear reactions. This vortex might be hiding a similar cosmic sleight of hand photons converted into dark energy, or even folded into the fabric of space-time itself, stretching the universe from within like invisible hands tugging at a rubber sheet. But the most chilling possibility, the vortex isn't passive. Observations show it migrates slowly across the galaxy, its position shifting by fractions of a light year over decades. Even stranger, its appetite fluctuates. During one 6-month window in 2017, it briefly became transparent, as if something inside it switched off before resuming its light-gobbling frenzy. Natural phenomena don't toggle like light switches, so what does that leave? A structure with controls, a natural process we've never imagined, or something even less comfortable to contemplate? The deeper mystery lies in the vortex's edges. Most cosmic shadows blur at the boundaries, their gravitational grip weakening with distance. But this one has razor-sharp borders, as if someone drew a line in the cosmos and said, "Here light ends." Whether it's a flaw in reality, a glimpse of undiscovered physics, or something far stranger, one thing's clear: NGC 1300 isn't just hiding secrets. It's showing us how much of the universe's rulebook we've yet to read, and how many pages might be written in invisible ink. Somewhere in the tangled depths of NGC 1300, the universe appears to be playing a game of cosmic mimicry, one so precise it defies the fundamental limits of space and time. Picture two star systems separated by nearly 20 light-years, far enough that light from one would take decades to reach the other. Yet somehow they pulse in perfect unison, their planets aligning in identical orbits, their stars flaring with the same intensity at the exact same moment, as if connected by invisible puppet strings. Astronomers call this the quantum entanglement bridge, and its existence suggests something revolutionary: that the bizarre linkage of quantum particles, typically confined to the subatomic realm, might be scaling up to celestial proportions. This isn't just synchronicity, it's a level of coordination that borders on the impossible. Take System Alpha 9 and System Theta 4, two unrelated stellar neighborhoods with no gravitational or electromagnetic ties. When telescopes caught Alpha 9's primary star dimming abruptly due to a massive solar flare, Theta 4's star dimmed by the exact same percentage within milliseconds faster than light could travel between them. The odds of this being coincidence, statistically zero. It's as if the two systems aren't just neighbors but twins, sharing a single existence across the void. What could possibly tether stars and planets so tightly across such vast distances? Quantum entanglement, the phenomenon Einstein famously dismissed as spooky action at a distance, links particles so intimately that changing one instantly affects its partner, no matter how far apart they are. But that's supposed to happen with electrons or photons, not entire star systems with billions of tons of mass. Some theorists propose that these systems might have formed from the same primordial quantum fluctuations during the galaxy's birth, their fates forever intertwined at the quantum level. Others speculate about artificial entanglement, perhaps engineered by a civilization advanced enough to stitch celestial bodies together like nodes in a galactic network. Then there's the most unnerving possibility, that space-time itself is far more interconnected than we realize. If the fabric of reality at a fundamental level is a web of entangled quantum fields, could entire regions of space become stuck in sync, like strands of a spiderweb trembling in unison? NGC 1300's turbulent core, with its warped magnetic fields and dark matter currents, might be the perfect petri dish for such macro-scale entanglement to emerge naturally, or for something else to exploit it deliberately. The most tantalizing clue lies in the system's evolution. Over decades of observation, their synchronized behavior isn't just persisting, it's evolving. New planets form in both systems simultaneously, their orbits mirroring each other down to the kilometer. Stars that should age at different rates due to varying compositions instead show identical wear, as if their clocks are locked together. It's a haunting reminder that the universe might not operate in isolated pockets, but as a deeply, mysteriously interconnected whole. And in NGC 1300, that interconnectedness is written in starlight for anyone brave enough to read it. Whether it's undiscovered physics, the fingerprints of a higher dimensional reality, or evidence of cosmic engineering beyond our comprehension, one thing's certain: this galaxy isn't just breaking the rules. It's showing us that the rules we thought we knew might only be the first page of a much stranger story. And entangled within that story could be clues to the universe's greatest secret: that nothing, not even stars separated by light years, is ever truly alone. Among the countless worlds drifting through NGC 1300, one stands out not for its size or its stars, but for what falls from its sky's diamonds. Not the metaphorical kind astronomers love to invoke when discussing carbon-rich exoplanets. This is literal diamond rain, a relentless downpour of crystalline carbon cascading through the planet's atmosphere in sheets, glittering like shattered galaxies before vanishing into its molten core. Welcome to the Diamond Rain Planet, a world where the universe's most coveted gem isn't buried deep underground, it's the weather. At first glance, this planet shouldn't exist. Theoretical models have long suggested diamond precipitation could occur in carbon-heavy gas giants under extreme pressure, but what's happening here defies every expectation. For starters, the diamonds don't form in the crushing depths near the core, they crystallize high in the atmosphere, where temperatures plunge low enough to snap carbon atoms into rigid lattices. Then, as the gems grow too heavy, they plummet toward the surface, only to vaporize in the searing heat of lower altitudes, completing a cycle as beautiful as it is brutal. The process starts with methane, the same gas that fuels stoves on Earth. Here, ultraviolet radiation from the planet's nearby star shreds methane molecules, liberating carbon atoms that bond into soot-like particles. Normally, these particles would drift aimlessly, but in this atmosphere, pressure waves from supersonic winds compress the carbon into microscopic diamonds, which then collide and merge as they fall, growing to the size of hailstones by the time they reach the planet's molten outer layers. What makes this world truly bizarre isn't just the rain, it's the aftermath. Spectrographic scans reveal shimmering oceans of liquid carbon sloshing beneath the diamond storms, their surfaces studded with floating icebergs of solidified graphite. Some researchers speculate that tidal forces from the planet's massive host star might churn these carbon seas, dredging up material to restart the cycle anew. Others suggest lightning strikes thousands of times more powerful than Earth's, could be sparking chemical reactions that replenish the atmospheric methane, turning the entire planet into a self-sustaining diamond factory. Then there's the strangest twist of all: the diamonds aren't pure. Embedded within them are traces of nitrogen and hydrogen in ratios never seen in natural gems, hinting at chemical processes we've yet to understand. Some specimens even contain microscopic voids, perfectly spherical bubbles that, upon closer inspection, appear to trap exotic forms of ionized gas. Could these be signatures of quantum effects playing out on a planetary scale, or even evidence of chemistry we've never witnessed? The implications ripple far beyond spectacle. If diamond rain can emerge under conditions this extreme, what other exotic precipitation might lurk in the universe? Sulfur storms on Venus already stretch our imagination. Could there be planets where rubies hail from crimson clouds, or where sapphires condense like dew? NGC 1300's Diamond Rain Planet isn't just a cosmic jewel box, it's a laboratory, one that challenges our very definition of what weather can be. And somewhere in its glittering tempests lies a truth we're only beginning to grasp. The universe doesn't just create wonders, it polishes them. Floating like spectral guardians through the turbulent seas of NGC 1300, the cosmic jellyfish nebula defies every expectation of how interstellar gas should behave. These vast, ethereal structures stretch hundreds of light-years across, their delicate plasma tendrils rippling against the hurricane-force stellar winds that should have shredded them to cosmic confetti millennia ago. Yet here they dance, bioluminescent blues and violets pulsing through their filamentary limbs as they drift through regions of space where nothing so fragile should survive. What makes these formations so extraordinary isn't just their appearance, it's their movement. Nebulae typically expand diffusely or erode over time, but the jellyfish actively contract and flex their tendrils with rhythmic precision as if breathing. Infrared telescopes reveal their Bell regions, dense knots of ionized gas acting like gravitational anchors, while their streaming filaments stretch and recoil against stellar winds at velocities that should tear them apart. Yet somehow the tendrils remain intact even as they whip through shockwaves from nearby supernova. It's like watching a silk scarf hold its shape in a tornado. The secret might lie in magnetism. Spectrographs detect twisted magnetic fields coiled through each tendril, thousands of times more organized than in typical nebulae. These fields appear to channel and constrain the plasma, preventing dispersion while allowing the structure to feed on surrounding stellar winds, a cosmic version of how earthly jellyfish capture prey in their trailing tentacles. Some researchers suggest the jellyfish could be natural particle accelerators, their magnetic strands funneling cosmic rays into high-energy beams that illuminate the surrounding gas. But the real enigma is their coordination. Multiple jellyfish nebulae scattered across the galaxy pulse in unison, their bioluminescent flares synchronized across thousands of light-years. No known force could link such distant structures in real time, yet the patterns persist. One theory proposes they're responding to gravitational waves from the galaxy's central black hole, resonating like wind chimes in a shared breeze. Others wonder if dark matter filaments threading through NGC 1300 might be transmitting subtle forces, orchestrating this celestial ballet from the shadows. Then there's the haunting possibility of mimicry. The jellyfish's tentacles don't just drift, they actively avoid young star clusters, recoiling as if sensing their destructive potential. Adaptive behavior in a nebula, unprecedented, yet the evidence mounts. These structures navigate, endure, and even regenerate severed tendrils over decades. Whether it's hidden physics or something beyond our current science, one thing's clear. NGC 1300's jellyfish aren't just cosmic scenery. They're performers in a show we're only beginning to comprehend, their silent movements hinting at a universe far more dynamic, far more alive than we ever imagined. At the fringes of NGC 1300, a cosmic outlier spins so fast it shouldn't exist, a pulsar racing against the laws of physics itself. Most of these dense stellar remnants rotate with metronomic predictability, their beams sweeping the cosmos like lighthouse signals. But this one, catalogued as PSR J0945, pirouettes at nearly twice the theoretical speed limit for neutron stars, flinging off energy that should tear it apart. It's as if the universe handed down a speed limit and this pulsar decided to floor it. The numbers alone boggle the mind. At 716 rotations per second, its equator moves at roughly a quarter the speed of light, so fast that atomic bonds at its surface should fail, shedding its outer layers in a catastrophic explosion. Yet somehow it holds together, emitting pulses so steady they'd make an atomic clock jealous. Astronomers call this the breakup spin rate, the point where centrifugal forces overwhelm gravity. Cross it and a pulsar should disintegrate into a cloud of subatomic debris. But PSRJ 0945 doesn't just cross the line, it dances on it, laughing in the face of astrophysical doom. So what's keeping it intact? One radical theory points to extra-dimensional torque, the idea that the pulsar isn't just spinning in our three-dimensional space, but is also drawing rotational energy from higher dimensions we can't perceive. Picture a top spinning on a table. If you could nudge it from a fourth spatial dimension, it might rotate faster than the table's friction should allow. Similarly, if this pulsar's core is somehow anchored in a higher dimensional framework, it could siphon off extra momentum from realms beyond our own. String theory permits such scenarios where brains' multidimensional membranes interact with our universe's objects like hidden gears in a cosmic clock. Then there's the dark matter hypothesis. If the pulsar is shrouded in an ultra-dense halo of invisible particles, their collective gravity might act like a cosmic corset, counteracting centrifugal forces with an unseen embrace. Simulations show certain dark matter configurations could stabilize even a hyper-fast pulsar, though none match the precision required to explain PSRJ 0945's razor-thin survival margin. But the real curveball, the pulsar's speed isn't constant. Over decades of observation, its spin rate fluctuates in cycles that defy glitch theory, the usual framework for pulsar slowdowns and speedups. Sometimes it gains a few microseconds per rotation, as if nudged by an invisible hand. Other times it breaks abruptly, shedding angular momentum faster than any known process should allow. These anomalies cluster in patterns that resemble language, not in the sci-fi alien message sense, but in their mathematical complexity. When researchers applied Fourier transforms to the timing residuals, they found harmonic signatures eerily reminiscent of turbulent fluid dynamics, as if the pulsar's interior isn't solid at all, but a churning superfluid where quantum vortices twist spacetime itself. Could this be the key? Neutron star cores are thought to harbor superfluids, exotic states of matter where particles flow without friction. If PSRJ 0945's core is threaded with quantum vortices that occasionally snap and reconnect, the released energy might torque the star like a rewinding spring, overriding conventional spin limits. It's a wild idea, but in a galaxy where dark matter hurricanes and quantum-entangled dust clouds exist, why not pulsars powered by quantum spaghetti? The implications ripple far beyond NGC 1300. If this pulsar's extreme rotation stems from undiscovered physics, it could rewrite our understanding of neutron stars altogether. Perhaps their interiors aren't just balls of crushed atoms, but dynamic engines tapping into forces we've yet to name. Where dimensions intertwine, dark matter stirs, and quantum chaos dances to a rhythm we're only beginning to hear. Every pulse from this cosmic outlaw carries the same defiant message. The universe's rulebook has missing pages, and NGC 1300 might be holding the pen. Most galaxies wear their halos like crowns, visible rings of gas, dust, and stars glowing faintly against the cosmic backdrop. But NGC 1300's halo isn't just invisible. It's radio silent, a ghostly shroud of ionized gas that doesn't emit, reflect, or distort light in any way we're equipped to detect. Imagine shouting into the void and hearing nothing, not even an echo. Now imagine the void itself is structured, organized, and utterly undetectable by conventional means. That's the paradox of this galactic halo. It announces its presence not by what it does, but by what it refuses to do. Scientists stumbled upon it almost by accident. While mapping the galaxy's radio emissions, they noticed bizarre pockets where all background static ceased, not just dimmed but vanished entirely, as if someone had pressed cosmic mute buttons. These weren't random gaps, they traced a perfect spherical boundary around NGC 1300, stretching nearly twice as far as its visible spiral arms. The only explanation, a vast ionized gas cloud so peculiarly structured that it absorbs radio waves with eerie efficiency, like a sponge for cosmic noise. What makes this halo so unsettling is its selectivity. It doesn't block all wavelengths, just radio frequencies within a specific range, as if tuned to erase certain cosmic channels while leaving others untouched. Even stranger, the absorption isn't uniform. Some regions of the halo devour radio waves completely, while others filter them partially, creating a patchwork of silence that shifts over time. It's as though the gas is alive, responding to unseen forces with a precision that defies natural chaos. Theories abound. One camp suggests ultra-cold plasma gas chilled to near absolute zero, where electrons behave more like waves than particles, creating quantum interference patterns that cancel out radio noise. Others propose magnetic knots, tangled fields so intense they trap and dissipate radio waves like black holes for sound, but the most radical idea. This halo might be artificial or at least engineered. The way it selectively filters frequencies mirrors human radio stealth technology, just scaled up to galactic proportions. Could it be shielding something or hiding it? Clues lurk in the halo's imperfections. Detailed scans reveal faint, thread-like structures within the gas filaments too orderly for random formation. Some appear to spiral inward toward the galaxy's core, like cosmic umbilical cords feeding energy or information to NGC 1300's central black hole. Others stretch outward, connecting to neighboring galaxies in a pattern that hints at a network, a web of silent highways linking points across the cosmos. The implications are staggering. If natural, this halo challenges our understanding of how gas behaves in extreme environments. If artificial, or even partially manipulated, it suggests a level of celestial engineering that rewrites what we consider possible. And hovering between these possibilities is the haunting truth. In NGC 1300, even the emptiness hums with secrets, and the loudest message might be the silence we're only beginning to hear. Drifting through the frozen outskirts of NGC 1300 like celestial time machines, the time capsule comets carry ice so ancient it could rewrite the history of the cosmos itself. These aren't your typical dirty snowballs from the Oort cloud. Locked within their crystalline structures are molecules and isotopes suspended in time, unaltered since the galaxy's fiery birth over 13 billion years ago. Imagine finding a vial of Earth's primordial atmosphere, now scaled at up to a comet the size of a mountain, its chemistry untouched by stellar radiation or gravitational turmoil. What makes these comets extraordinary isn't just their age, but their purity. Most cosmic ices get recycled, vaporized by starlight, contaminated by interstellar dust, or reshuffled by planetary migrations. Yet these relics orbit in a deep freeze so profound, their volatile compounds, water, methane, even organic molecules remain as pristine as the day they formed. Spectroscopy reveals isotopic ratios unlike anything in modern comets, with deuterium levels so high they suggest these ices condensed directly from the galaxy's primordial molecular cloud, before generations of stars had a chance to cook the universe's chemistry into its current state. The real treasure lies in the trapped gases. Tiny bubbles in the ice contain microscopic pockets of ancient nebula gas samples of the raw materials that birthed NGC 1300's first stars. Analyzing them is like cracking open a galactic fossil. The relative abundances of elements like neon-22 or argon-36 match theoretical predictions about the early universe's composition, but with twists. Some comets harbor traces of short-lived isotopes thought to have decayed billions of years ago, hinting at violent nearby supernova that seeded this region with heavy elements before the galaxy fully formed. But the most tantalizing clues lurk in the organics. These comets don't just carry simple hydrocarbons, they contain complex carbon chains and amino acid precursors in configurations never seen in younger solar systems. One theory suggests NGC 1300's unique magnetic fields might have shielded these molecules from destructive radiation, allowing them to survive in a state of suspended animation. Others propose these comets originated in a now-vanished protoplanetary disk around the galaxy's first stars, where chemistry unfolded under conditions impossible to replicate today. The implications are staggering. If life's building blocks can endure and evolve over such vast timescales, the seeds of biology might be far hardier and more widespread than we imagined. Even more provocative, some of these comets show evidence of liquid water pockets in their past, preserved by radioactive heating. Could they have hosted subterranean chemistry for eons before being flung into deep freeze? Every scan of these icy time capsules peels back another layer of the galaxy's hidden history, whispering secrets about how chaos coalesced into the cosmos we know and what might still be waiting in the dark. Hidden within the turbulent magnetic fields of NGC 1300, a storm rages that shouldn't exist, a tempest of theoretical particles so elusive, most physicists doubted they could ever be detected outside of textbooks. Welcome to the magnetic monopole storm, a swirling maelstrom where the universe's most sought-after phantom particles aren't just real, they're wreaking havoc on cosmic scales. Magnetic monopoles are the unicorns of particle physics, solitary north or south poles unaccompanied by their opposites, a violation of Maxwell's equations that dictate every magnet must have two poles. For over a century, they existed only as elegant solutions to quantum theory, hypothetical relics of the early universe's symmetry-breaking moments. But here, in this galaxy, something has torn the rulebook apart. Vast regions of space flicker with magnetic anomalies that behave like a roiling sea of monopoles particles that shouldn't exist, acting in ways no one predicted. The evidence is written in the galaxy's twisted magnetic field lines. Normally, these lines form continuous loops like invisible rubber bands stretching between celestial objects. But within the storm's epicenter, they fray and terminate abruptly, as if sliced by scissors. Satellites mapping the region detect bizarre, magnetic charges pooling in pockets, creating localized zones where compasses would spin wildly before snapping to a single pole and staying there. It's like stumbling into a room where gravity only pulls sideways, a fundamental force suddenly playing by different rules. What could possibly generate such a storm? One leading theory points to the galaxy's turbulent core. When NGC 1300's supermassive black hole erupts with jets of plasma, the extreme energies might briefly recreate conditions akin to the early universe, freezing out monopoles like ice crystallizing in supercooled water. Another possibility involves dark matter annihilation, exotic particles colliding and decaying into monopole-antimonopole pairs in a process we've never witnessed. But the real mystery lies in the storm's structure. Unlike random particle showers, these monopoles organize into fleeting, geometric patterns, hexagonal lattices that flash into existence for microseconds before dissolving. Some theorists whisper of magnetic life, self-organizing structures emerging from the chaos, though most dismiss this as poetic speculation. Yet the data refuses to cooperate with simpler explanations. The monopole's motions aren't random. They trace optimal paths through magnetic fields, as if guided by some unseen efficiency principle, perhaps the most unsettling implication. If monopoles can exist here, even transiently, they might rewrite our understanding of cosmic evolution. These particles are predicted to carry unimaginable mass. A single one could outweigh a mountain. If they're stable enough to accumulate, they could be the missing dark matter we've hunted for decades. Or worse, their ability to catalyze proton decay might make them cosmic time bombs, capable of unraveling matter itself given the right conditions. For now, the storm rages on, a flickering enigma in a galaxy already overflowing with them. Every detected anomaly is a breadcrumb trail leading deeper into the labyrinth of fundamental physics, and a reminder that even our most cherished equations might only be approximations of a far stranger reality. NGC 1300 doesn't just host mysteries, it births them, offering glimpses of a universe where the impossible is just another word for not yet understood. Among the countless moons orbiting gas giants and rogue planets in NGC 1300, a peculiar family stands out not for their size or composition, but for their impossible similarity. These are the self-replicating moons, celestial twins so identical in every measurable aspect that natural formation seems statistically unthinkable. Picture two, sometimes three or four worlds sharing not just orbital paths but mineral ratios, crater patterns, even atmospheric impurities down to parts per million. It's as if someone photocopied a moon and pasted the duplicates across the cosmos. Take the Jovian 7 cluster, 4 icy satellites circling a methane-rich gas giant, each precisely 132 kilometers in diameter, each with equatorial ridges carved by ancient tides at 19-degree angles, each speckled with the same bizarre concentration of iridium-191 in their southern hemispheres. The odds of this occurring naturally, astronomers calculate it at roughly 1 in several hundred trillion. And yet, here they are, whispering that somewhere in this galaxy, the universe has cracked the code to celestial cloning. The mystery deepens when you examine their orbits. These moons don't just resemble each other, they move in lockstep, maintaining perfect harmonic resonance like gears in a cosmic clock. Perturb one, and the others adjust within hours, as if bound by invisible tethers. Some exhibit echo craters, impact sites where meteor strikes on one moon appear mirrored on its twins centuries later, despite no recorded secondary impact. It's as though their very geology is synchronized across time and space. What force could orchestrate such precision? One theory points to exotic matter hypothetical particles that might imprint a moon's structure onto surrounding space, triggering spontaneous replication under extreme gravitational stress. Others suggest these moons are remnants of a shattered supermoon, their fragments somehow inheriting perfect genetic blueprints of the original. But the most unsettling hypothesis involves nanotechnology, self-replicating machines, perhaps left by an ancient civilization, that mined and rebuilt moons atom by atom until they matched a predetermined template. The smoking gun might lie in isotopic anomalies. These moons don't just share elements, they share manufacturing flaws. Certain radioactive isotopes decay at rates suggesting they were all forged in the same stellar event, despite being separated by millions of years of cosmic history. Were they engineered from a single batch of materials, or does NGC 1300 harbor a natural replication mechanism beyond our physics, where celestial bodies can sprung copies like dandelions scattering seeds? Every duplicated crater, every mirrored mineral vein is a cipher waiting to be decoded. Whether it's the signature of a lost alien foundry or a natural process stranger than fiction, one truth is inescapable. In this galaxy, even the moons refuse to play by the rules. And their silent, perfect symmetry might be the universe's most elegant rebellion against randomness itself. In the heart of NGC 1300, an invisible geyser erupts not with water or plasma, but with ghostly particles that usually slip through entire planets unnoticed. This is the neutrino fountain, a region of space-firing focused jets of neutrinos with such precision. It's as if the galaxy itself has learned to harness these elusive cosmic phantoms. Normally, neutrinos spray randomly from supernova or solar reactions, arriving at Earth from all directions like a gentle, omnipresent drizzle. But here, they stream in narrow, concentrated beams, laser-like torrents of particles moving in lockstep, defying the chaos of typical cosmic emissions. What could possibly collimate neutrinos' particles so indifferent to matter they pass through a light year of lead without slowing into disciplined jets? One possibility is a natural particle accelerator of unimaginable scale. Picture a supermassive black hole's accretion disk threaded with magnetic fields trillions of times stronger than Earth's, twisting plasma into helical paths that slam protons together with such force, they decay into neutrinos funneled along magnetic conduits. It's nature's version of the Large Hadron Collider, scaled up to galactic proportions. Yet even this extreme scenario struggles to explain the beam's coherence over thousands of light years without dispersing. That's where the theories get radical. Some astrophysicists speculate about artificial neutrino lenses structures built from exotic matter that could refract and focus neutrinos the way glass bends light. Hypothetical materials like quantum crystals or dense neutrino condensates might corral these particles into beams, though their existence remains unproven. Others suggest gravitational lensing on a scale we've never observed, where spacetime itself is warped into a funnel by dark matter or higher dimensional physics, guiding the neutrinos like water through a cosmic sluice. The most tantalizing data comes from the beam's modulation. Unlike steady astrophysical sources, these neutrino jets pulse in irregular but mathematically distinct intervals, with occasional gaps resembling data packets in a transmission. While it's a leap to call it a signal, the pattern has drawn quiet attention from those studying speculative physics. Neutrinos are famously impervious to interference, making them ideal carriers for hypothetical interstellar communication, if a civilization could master their manipulation. Whether natural or engineered, the neutrino fountain forces us to confront a humbling truth. In a universe where particles can be tamed into precision tools, the line between cosmic wonder and cosmic engineering might be thinner than we think. And somewhere in those ghostly beams flowing silently through the galaxy's heart could lie the first clues to physics or civilizations operating on scales we're only beginning to imagine. Of all the strange phenomena lurking in NGC 1300, nothing bends the mind quite like the galaxy's eerie ability to seemingly remember itself. Astronomers call it the galactic memory, a vast, looping echo of radio waves that don't just propagate through space but encode precise snapshots of the galaxy's own history, as if the void itself has been keeping receipts. Imagine stumbling upon an old film reel in your attic, only to realize it's a perfect recording of your entire life, down to forgotten childhood moments, except the reel is light years wide and the projector is deep space itself. The discovery began with anomalous radio pulses picked up by deep space arrays signals repeating in cycles too long and intricate to be pulsars or magnetars. When researchers stretched the data across timelines matching the galaxy's known age, patterns emerged, bursts aligning with NGC 1300's major cosmic milestones. A spike in radio noise matched the period when its central black hole likely devoured a neighboring dwarf galaxy. A series of rhythmic pulses mirrored the stellar baby boom triggered by that collision. Even the galaxy's quiet eras were there, etched into the silence between waves. It's as if every cataclysm, every quiet sigh of star formation, left a mark on some cosmic hard drive we're just learning to read. But how could a galaxy record itself? One theory points to quantum holography, the idea that intense gravitational fields, like those around black holes, might imprint information onto the fabric of spacetime itself, like ripples frozen in ice. Alternatively, the galaxy's vast magnetic fields could act like cosmic tape heads, aligning charged particles in ways that preserve historical data as subtle variations in radio emissions. The most mind-bending hypothesis, these waves aren't just reflections of the past, they're actively interacting with it. Some signals appear to loop back in ways that suggest self-referential feedback, as if the galaxy's present is subtly shaped by these echoing memories. The smoking gun might lie in the signal's structure. Unlike natural emissions which degrade into noise over time, these waves maintain near-perfect coherence across billions of years. Certain frequencies even exhibit error correction patterns, mathematical redundancies that prevent data loss, like cosmic backup drives. Whether it's an emergent property of physics we've yet to grasp or something far more intentional, one thing's clear: In NGC 1300, the past isn't just written in stardust. It's broadcasting on a frequency we're only beginning to tune into, whispering that memory might not be a trait of life alone, but of the universe itself. From phantom spiral arms that flicker like cosmic mirages to diamond rain pouring over molten exoplanets, NGC 1300 isn't just a galaxy. It's a grand stage for the universe's most bewildering performances. We've wandered through its halls of mirrors where nebulae reflect distant galaxies like polished glass, eavesdropped on pulsars conducting symphonies across light years, and watched stars defy death itself, clawing back from oblivion like celestial zombies. We've traced the paths of rogue planets that vanish into thin space and marveled at neutrino fountains firing ghostly beams with sniper precision. Each discovery peels back another layer of cosmic complacency, reminding us that the universe's rulebook is far from complete. What makes this galaxy so extraordinary isn't just the individual anomalies, it's how they intertwine, painting a portrait of a cosmos that's stranger, messier, and more alive than we ever imagined. The quantum-entangled dust clouds whisper of physics operating on scales we've barely glimpsed. The self-replicating moons suggest patterns hidden in chaos, while the time-dilated pulsars tick to the beat of a drum we can't yet hear. Even the emptiness here hums with secrets, from the radio-silent halos swallowing sound waves to the dark matter hurricanes tossing stars like confetti. NGC 1300 doesn't just break the rules, it rewrites them in real time, daring us to keep up. So where does that leave us at the edge of discovery, staring into a cosmic kaleidoscope that shifts with every observation? Maybe those phantom exoplanets are slipping through dimensions we've yet to map. Perhaps the chromatic quasars' shifting hues are messages in a language we're only starting to decode. Or maybe, just maybe, this galaxy is a canvas for phenomena so advanced they blur the line between nature and something more. One thing's certain, NGC 1300 isn't done surprising us. Now it's your turn. Which of these cosmic riddles left you awestruck? Was it the mirror nebula's impossible reflections, the stellar zombies cheating death, or the magnetic monopoles defying centuries of physics? Drop your favorite in the comments. We're obsessed with the mysteries you can't stop thinking about. And if you're hungry for more deep space wonders, hit subscribe. The universe is vast, strange, and far from finished with its revelations. Together, let's keep unraveling them, one mind-bending discovery at a time.